Well, hello everyone, and welcome to the July 2025 edition of the St. Louis Java Users Group. For those who don't know, the St. Louis Java Users Group is an informal group. Our first meeting was in May of 1997, so we're one of the older Java users groups around. Attendance is free. We don't maintain a formal membership list. Normally, we meet on the second Thursday of every month except December, when there is no meeting. There's just too many things going on over the holidays for us to organize a meeting in December. For those of us who would like to join us in person, you can join us for food and social at 6 p.m. and we try to start the meeting at about 6:30. And our normal meeting location for folks who join us in person is in the Object Computing Incorporated training room, and they're at 12,140 Woodcrest Executive Drive, Suite 310, and that's in St. Louis, Missouri. I'd like to introduce the other members of the St. Louis Java Users Group Steering Committee. So from left to right, we have Zach Klein, Ted Doyle, Robert Levitt, Wei Chi Gao, Bruce Alspaw, that's me, there at the end. And you can reach all of us on the steering committee if you send an email to that address there at the bottom of your screen. That's javasigsc@googlegroups.com. The St. Louis Java Users Group would not be possible without the support of our sponsors. So from left to right, we have Object Computing Incorporated. They have sponsored the training room for us, and all the Google Meet and everything that allows us to have the live stream and record everything. And they've saved us many times, and they've been with us since 1997, and they've bailed this group out so many times I can't even begin to count how many times they've helped us out. Like tonight, for instance, when they sponsored the pizza. So thank you to OCI for sponsoring the pizza tonight. At the end of this meeting, we will be raffling 2 Manning ebooks and 2 JetBrains licenses of your choice, but you must be present to win. So if you're watching the YouTube recording, I'm sorry you're too late. You can't win that way. And if you'd like to join the raffle at the end of the meeting, just stay online and or stay in the room, and you can enter the raffle there. Now, the Jug is in need of additional sponsors, so if you know of a potential sponsor, please email us at the steering committee. And again, that's javasigsc@googlegroups.com. Manning has sponsored a 40% off discount code that you can use on any Manning products. And when you go to their online store, when you check out, you can put in that discount code JUG13. KCDC is coming up August 13th through the 15th, and I think, I should have taken that down. I don't think the early bird tickets are still available. However, you can get more information about that conference if you go to that website there at the bottom of your screen, www.kc.info. UberConf is coming up here pretty darn quick. That'll be at the Westminster Hotel in Denver, Colorado. And those are the same people that sponsor the No Fluff, Just Stuff conference. And we work with Chase Zimmerman on that, and he gives us discount codes for that conference. So if you want $200 off that conference, you can go to the website there, uberconf.com, and put in that discount code Uber25 Chug2. For upcoming presentations, you can check on the Meetup site, but we've got scheduled now Durable Execution with Temporal by Tom Wheeler of Temporal. And on September 11th, we got a really interesting presentation, Better Understanding Through Bytecode, and by Jason Clark. And he actually works at GitHub. And they're going to talk about, in effect, it's like programming in assembly language, but it's JVM assembly language. So what is that compiler actually generating? And how does it run when you run a Java program on the JVM? Well, we're going to find out here on September 11th. So if you like to keep up with our presentation schedule, that's easy to do. Just watch our meetup group, meetup.com/gatewayjug. And as we schedule presentations, we post them on our meetup group. And we often get asked, are presentations recorded? And yes, they are. I've been uploading them to my YouTube channel, and there's the address. I'll probably have this one uploaded here, and probably sometime over the weekend, but it's youtube.com/@ and my name. So if you're interested in giving a presentation or becoming a Jug sponsor, again, you can contact the steering committee through that address, javasigsc@googlegroups.com. So enough about me. Now it's time for the real reason you came to this meeting, to hear about how to use MySQL Document Store with Java by our speaker, Scott Stroz. So what I need to do is I need to find the magic button to stop presenting here so that Scott can now take over the screen and share his screen for the presentation. So why don't you take it away here, Scott?
Thanks, Bruce. I'm really, really happy to be here. So my name is Scott Stroz. I am a developer advocate for Oracle, where I work with the MySQL team. And tonight we're going to talk about using MySQL Document Store with Java. If you're not sure what MySQL Document Store is, don't worry, I'm going to get into that. But before we do anything else, I need to do the obligatory I love me slide. I am a full stack developer, and I have been a full stack developer for longer than the term full stack developer has actually existed. I'm an avid golfer, and you're going to see that I'm not a good golfer in some of the demos that I'm going to be showing that we're going to be going off. And then I have the absolute best office mate in the world. This is my dog, Murphy. He's a Labradoodle, and he spends pretty much all day, every day with me in the office. And Murphy knows more about databases and code than any other dog in the world, because when I have a problem, I turn to him and I start explaining the problem, and then I just look into his eyes and I get the answer. But this is Murphy as a puppy. This is Murphy as the 112-pound beast that he is now. We had no idea he was going to be getting that big, but he is a huge, huge dog. Fortunately, he's not the kind of big dog that thinks they're a lap dog, but he always wants to be as close as he possibly can to you. So to give a quick overview of what we're going to cover tonight, we're going to talk a little bit about the differences between a NoSQL and relational databases. Going to give you a very, very high overview of MySQL Document Store. We're going to talk about how the data of a MySQL Document Store is structured. I'm going to go over how to access and connect to a document store with Java. I have quite a few examples of using the CRUD API with the document store. And then the last demo, and I shouldn't say the last demo, it's not the last demo, but my favorite demo is showing how you can use raw SQL to query our documents. And I spent hours when I first put this presentation together trying to come up with a query that would make it like, that would kind of give it like that wow factor. And hopefully you guys will agree. So in the development world, NoSQL has kind of taken off in recent years. I think maybe it's eased up a little bit, but when NoSQL databases first came out, my brain just couldn't handle it, because I'm kind of old school, where I think your data should be structured and everything should be in tables, and you should have the proper relationships and indexes so everything's all nice and neat. And I didn't understand the advantages of NoSQL, but there actually are some. You can actually you can have faster development time, and that's mostly because it's easier to modify the schema. So if you're using a relational database and you need to add a property to something, you have to create a new column. And then you have to make sure you have the right data type. And then depending on the project you're working on, that script may need to be signed off on by a DBA. And then it also needs to be promoted through the different levels, go from QA to staging to production, whatever. So it could take a while before you actually can start using that new column. Whereas with a JSON, you just add a new property to your JSON string, boom, your scheme has changed. And also, pretty much every NoSQL implementation that I've seen and played with has a simple CRUD API for retrieving and managing data. Some of the downsides is the data is unstructured. And aside from the fact that unstructured data makes me all twitchy, it is difficult to run queries for reporting. In a lot of instances, it's not impossible. It's just very difficult, and you have to run through a lot of hoops. Imagine trying to do aggregate or analytics on JSON data in a document store. It's difficult to do. So on the relational database side, data can be and should be structured and organized. Now, just because you're using a relational database doesn't mean your data is going to be structured and organized, which is why I said it should be. Which means if it is, structured and well organized, it's going to be easier to run queries for reporting or analytics. Some of the downfalls is there is a slower development time. I've worked on projects before where if we had to make a change to a database, we had to provide what we think was the script to do it to the DBA. The DBA had to sign off on it. And then it had to be reviewed by other people. And literally it would take, like if you needed to add one column to a table to add a piece of functionality, it could take up to a week in order for that to be ready for you in the development database to actually start working on that piece of functionality. And also, as your data, your database becomes more complex and there's more relations added to a database, CRUD operations can become a little bit more complex, especially for doing inserts and also for doing deletes. If you're doing hard deletes, you want to make sure that you don't have any orphan records from relations. So it can become a little bit more complex if you're not using an ORM. I know not everybody does, but it can be a little bit of a pain to do CRUD operations when you have a really complex database with a lot of different relationships. So what is MySQL Document Store? And before I continue on, I need to explain something. So I first started using MySQL back in 2001. And up until 2022, I had never known anybody who referred to it by anything other than MySQL. Everybody I knew from the day I first started using it till the day I started at Oracle called it MySQL. I discovered when I started working at Oracle that it's actually supposed to be pronounced MySQL. Now, a lot of people at Oracle aren't going to give you grief if you call it MySQL because we understand, hey, that's what people know. So if you hear me say MySQL as opposed to MySQL or vice versa, it's because in the 3 years I've been here, my brain still hasn't completely made that switch over. So sometimes I fall back into the old MySQL rather than MySQL. But I've had people say, why do you use both? And I've found that it's better for me to admit up front why. So MySQL Document Store is a JSON document storage solution that's built on top of MySQL. The documents are actually stored in an InnoDB table in a MySQL database. And one of the advantages which I think is one of the big advantages, is the fact that because it uses the InnoDB storage engine, it's fully ACID compliant, which is something that other NoSQL implementations or NoSQL solutions can't claim. It actually uses the JSON data type, and it's not listed here, but I think one of the huge advantages of using MySQL Document Store as opposed to some other document storage solutions is the fact that because it's stored in a database table using the JSON data type, that means that we can actually use raw SQL to query the data the way that we want or need to do that might be difficult or impossible to use the CRUD API. And also there is an easy to use CRUD API. It's, we are one of the NoSQL solutions that does have a easy to use API for managing data. So some of the nomenclature when you're dealing with NoSQL is a little bit different than what we're used to when we're talking about relational databases. We talk about schemas and collections and documents. So a schema is the same thing as a schema or database. I know in some places a schema and a database are different things, but in MySQL, schema and database, same thing. So if you hear me say schema, I say database, and if you hear me say database, I'm also talking about schema. It's actually interesting in MySQL that if you do, you can do create database or create schema, and it does the same exact thing. You'll hear people talk about a collection of documents. And basically, the way to look at that is the collection in Document Store is equivalent to a table. So if we have a collection named users, that will be a MySQL table that will store the JSON information for the users that are being persisted. And then lastly, a document, which is the actual JSON itself, is kind of the equivalent of a row in the table. It's not exactly the same thing, but I think conceptually it helps people to understand that when you're talking about a document, you're talking about one particular item in the database. Now, when you create a new collection, so using the API, you can actually, or the DevX API, which I'm going to talk more about in a bit, you can actually do create collection, and it'll create the table for you that's going to house your documents. And that table is actually going to include, by default, 3 columns. The first is going to be _ID, which is a var binary, and it is automatically generated. And then there's a column named doc, which is a JSON data type. That's the actual storage. That's where the actual document's going to be stored. So when we store our JSON using Document Store, it gets stored in the doc column. And then the other column is _JSON _schema, which is also a JSON data type. But what this is for is this is to actually validate JSON documents that are being persisted or updated in the database. Now, some people might be like, well, why do you want to validate something or validate a schema that's supposed to be schemaless? Granted, most times people are using NoSQL solutions. They don't really care about the schema. But I actually worked on a project with a very big retailer while I was at Oracle, and they had specific rules that they needed to be in place. So, for example, there was one particular property that had to be there. It was required. And if the JSON document didn't have that, they didn't want to save it, so that it would throw an error. And then there were other properties in their schema where, like the purchase date it had to be a valid date. Or there were some where they had to be numbers or integers or text of a certain length. So it couldn't be longer than, say, 50 characters or whatever. And by setting up the JSON schema here, we actually get automated validation, because if you try to save a document and it doesn't match what's in the JSON schema or what's defined in the JSON schema, then it actually throws an error when you try to save or update a document. Now, this is beyond the scope of this talk, but we can also create indexes on properties inside of JSON. And if you do that, it'll actually add more columns, which are generated columns that are then indexed to make it easier, or I should say, make it faster to retrieve some data. So how do we access MySQL Document Store? There's actually a tool called the X plugin, which used to be an external piece that you would have to install onto MySQL. However, since version 8.0.1, it's installed by default. So this means if you're using a newer version of MySQL, you already have access to Document Store. You don't need to worry about installing anything else. It uses what's called the X protocol through MySQL connectors, or a lot of places. Some people refer to them as SDKs. And connectors are available from Oracle. So these are official Oracle connectors for Node.js, C++, Python, PHP, .NET, MySQL Shell, and Java. There are also community-supported connectors for Go, Rust, and there's one other one that I can't think of right now. And obviously, the one that we're going to be talking about today is Java. Now, I will say the different the different implementations of the connectors do lead to some different syntax and some different different ways that the APIs actually work when you get into the finer details. But all of the top tier methods are pretty much going to be the same. So real quick about the demo. The demo is actually using a REST API that I built using Micronaut with Java as the language on the back end. It uses two different database connections, and I'll explain why a little bit later on. Most of the demo uses the XDev API, which is how we access Document Store. And I say most, again, I'll explain more about that later. And then the schema looks like the JSON blob that I have on the screen. Now, a little bit ago, I told you I was an avid golfer. And one of the things that I have done for the last, I think, 15 years is I have managed a golf league at the local golf course. It's grown over the years, and we currently have 80 golfers where we play 2 nights a week. Half of us play on Tuesday, half of us play on Thursday. And I actually wrote the web application that helps me manage the golf league. And what I did for this demo is I extrapolated the data from all the rounds of golf that have been played and stored in the database. It's not all the rounds in the league because we didn't have the web application for the first few years. But I took all of that round data and I actually put it into JSON because it's not stored that way regularly. But I figured this would be a good example to use stuff. And it includes stuff like the date the round was played, what the score was, information about the golf course that was played, the golfer's first name, last name, the net score. There's an array called hole scores, which basically shows what hole number it was, what the score was, what the par is, and then we figure out the relationship to par. There's also an adjusted score that's included in part of the JSON itself. So quick warning before I show you any code. This code is not production ready. And what I mean by that is there is practically no validation. There's almost no error handling. This is all just, this is how you do it. And I'm going to expect when you're using the demos that you're going to do it the way you want to. Obviously, you're going to want to add some other code to make sure that the data is in the right format or it exists in the way that you need it to exist before you push anything to production. So really, the only thing that you would need to know in terms of your Gradle dependencies, sorry, and I actually use Gradle for to build this, is you want to make sure you use the MySQL connector J. In this particular case, I'm using 9.0.0. I did mean to update that to the latest connector, which I believe is 9.3. But because of all the problems I had once I got it working, I didn't want to mess with it. I had problems getting the demos working because of something that got messed up in my configuration settings for Gradle. And after several hours, it was one of those things where I was like, don't make any changes. So the first thing we're going to talk about is I actually created a class called Score Service. And Score Service is what I use to actually interact with the document store. And to go over go over that code really, really quickly, we have a bunch of private variables. There's an object mapper, client factory, which comes from the connector J, the MySQL connector. There's a document store config, which contains the information about actually, the IP address, host, username, password, whatever. Client is something else that comes from the connector J, which is actually what we're going to actually be using to, CLI is a data type of client, which is what we actually use to interact with the MySQL database. And then we have the URL, which is the JDBC URL, the name of the schema that we're going to be using, and the name of the collection. So when we instantiate this class, we pass in the document store config, and we build the URL. So you'll see it says MySQL X for people who have used MySQL before. You'll probably recognize the fact that there is an extra character in there, and that's the X. So we do MySQL X : // That is going to tell the connector that we want to connect using the X protocol. And by default, the X protocol is port 33060 as opposed to 3306, which is the legacy way that you connect. And here you'll see that we build the JDBC URL by using document store config get user, and then colon, and then password, and then at, and then host, and then colon, and then port, and then backslash, and then schema. We set the private variable for schema and collection because of the example I'm going to show later. Then I add some pooling information. For this particular demo, I didn't need pooling information, but I figured I'm going to add it just so it's there and people understand how to use it because it is kind of easy to do. And you'll see in the map that we create, we enable it. We say the max thread count is going to be 8, the max idle time is going to be 30 seconds, and the queue timeout is going to be 10 seconds. And then we set the private variable CLI to the result of client factory.getClient, and we pass it the JDBC URL, and then we also pass it the object mapper, or the values of the options themselves. And this is actually going to create a MySQL client that we can use to then hit the MySQL Document Store. So as I said, this is a Micronaut application. So I'm a big fan of Micronaut. I've been using it for quite a while. I'm not really a Java developer. I've kind of muddled through. I've worked on a couple of applications where we use Micronaut, and it was really, really easy to get up and running and understand how everything works. So the first demo is we create an endpoint, or I create an endpoint called \list. And it doesn't take any arguments. It doesn't take any parameters. And you'll see what we do is we actually call scoreService.getAllScores. And then we return the HTTP response okay and pass in getResult. And we pass scores into getResult. Now, what getResult looks like, it's just a way to split out the data and get an idea of how many items are in there and then the actual data itself. And I do this so that when I'm doing the demo, you can see that there's no smoke and mirrors, that it's actually working the way I say it's working as I'm saying it's working. So it's a way to, be like, oh, it wasn't a real demo. It's going to be a real demo. You'll see. And then inside of score service, here we have our method called getAllScores. And items 3, 4, and 5 are going to be the same for all of the examples I give using the XDev API or using the X protocol. So the first thing we do is we need to get the session. So we call get session, and that actually inside of the score service, it will return the a session from the CLI that we created. And then once we have the session, we need to get the schema. So we call session.getSchema and pass in the private variable of schema. And then lastly, we have to get the collection. Remember, the collection is the table we're talking about. So we do schema.getCollection, and we pass in this.collection. Now, could I have done this all in one line of code? Yes, but it would have been very difficult to read, and it would have been very difficult for you to see exactly what was going on. So I figured I'd break it up into 3 lines, even though I love one-liners. I'm a big fan of one-liners. But in this particular case, I just thought it'd be easy to read. So when we have our collection, the way we retrieve results is we call the method find. So here we do call.find, and then in order to actually make anything happen, we have to call .execute. If we don't call .execute, nothing happens. So you'll see we set the value of result into what comes back from call.find.execute, and then the next thing I need to do is I call a method called clean results. And inside of that, I return result.fetchAll. So this is actually going to give us all the records at once. I could iterate over result if I wanted to, but in this particular case, it seemed like it would be an easier example to do this. And I'm going to show you what clean results does and why in a second. And then the next thing we're going to do is we have to close the session. Make sure you close the session. And the reason why is if you don't close the session is going to stay open until the thread times out. And in some applications, you may run into problems. I actually ran into problems when I was first setting up this application because I didn't close the session and I was hitting the endpoint too quickly and it kept creating a new session and I ran out of threads. And then lastly, what we do here is we return the value of docs. So what I do here in clean results is basically I take the data that comes back from the query, and I basically make it a nicer looking JSON. What comes back is JSON, but it's not the type of JSON that we're really looking for. So what the JSON actually looks for is here. So you can see adjusted score. Instead of just being 46, adjusted score is actually an object that has a property called integer and a property called big decimal, both of which are 46. The course city has, instead of it being Charlestown, it has an object where it says string Charlestown. Again, this is JSON, but this is not really what we would be looking for if we're working with this data on the front end of an application. So that's why I clean up the results, and you'll see how that data comes back differently in a second. So let's show an example. So what I'm going to do is I'm actually going to hit the list all API or endpoint. And you'll see I'm going to click show anyway. And you'll see here that the count is 17,115. This means that there are 17,115 rounds of golf stored in the database. Now, it may have seemed like it took a long time for that data to come back from the database, but it didn't. And the reason why I'm saying that is because the data came back very quickly. It actually took Insomnia a while to render that data. Even after I said, hey, yes, show it all the time, it still took a while for it to render. It actually does come back pretty quickly, even on my laptop, my development machine. And then you'll see we have all the data here. So we have the adjusted score, the course information, the date. Note that this date, 7/8/25. Yes, this is actually information from golf league rounds that took place 2 nights ago. I imported that into the demos. I like keeping, whenever I give this talk, I always like pulling in the most recent data, just so that there's some, recent stuff that I can talk about. And you'll see it has the information about the whole scores, and then the last name, the net score, and then finally with the score that they had. Now, something to keep in mind when you use the find method of a collection, it is akin to using select star from in a regular query. So you're going to be pulling back every property, and you're going to be pulling back every row. There are not going to be too many cases where you're going to need to pull back every document that you have in your document store. And one way we have to limit them is by using limit and offset. So this is actually going to be good if you need to paginate your data. So instead of listing everything and maybe having the client side handle the pagination, we can actually use limit and offset to paginate the data for us. So in this next endpoint, we have an endpoint definition where we have list, and then we have a parameter named limit, which is required, and then we have a parameter named offset, which is optional. And we pull in the information, excuse me. So we check to see we call in score service.get scores. We pass in limit because it's mandatory, it has to be there. And then if the offset parameter exists, we pass that in. If not, we pass in 0. If you pass in 0 as an offset, that means there is no offset, and it's just going to get everything up until the limit. And then again, you'll see we call get result and pass in the scores. So now in this instance of get scores, we have 2 parameters or 2 arguments that are passed in: limit and offset. Both of them are integers. And again, we do this. We get the session, get the schema, get the collection. And here you see, if you look at number 2, we call collection.find, and then we call .limit and pass in the limit value, and call .offset and pass in the offset value. And then we call .execute. We clean up the results. We close the section. We return the docs. Now, something to keep in mind when it comes to MySQL and the offset, because some databases actually handle the offset a little bit differently than others. And in MySQL, the offset is the number of records to skip before you start returning results. So let's say we had a database table that had 20 rows, and we wanted to get 5 at a time, but we wanted to get the second block of 5. We would do limit 5, offset 5, which means it would actually start returning rows from 6. And because we have a limit of 5, it would go, the rows would be 6 through 10. Some database solutions, the offset is a little bit different. It'll tell you on which one to start with rather than how many to skip. So in that particular case, we would have used offset 6 instead of offset 5. So I'm going to show you that result. If we go here, and you'll see we're doing a limit of 100. And we click send, and the results come back, and you'll see it shows 100. And this is actually the same exact record that we just saw. But now if we want to offset that, let's say we'll offset that by 2000. So we're going to skip 2000 rows, and we click send there. You'll see the ID is different. And also you see that this is actually from 2017 instead of 2005. So this was from 8 years ago. So far, when we've been doing using our API, we have been saying, basically, I want to return every property that exists inside of the JSON documents that are stored. And again, you're not always going to need every property. Sometimes you just want a scaled down version. And the cool thing there is we actually have a way to do that where we can define which data that we're going to be pulling back from our JSON documents. And that's by using the field method. Now here, I have an endpoint called best scores, and there is an optional limit parameter. And if you see down here, when we call best scores, if limit doesn't exist, we pass in a default limit, which in the score service is actually set to 50. So if I don't pass in a limit, it will only pull back the top 50 results. And then inside of score service ourselves, you'll see we have the argument that we're passing in for get best scores. That is, it's an integer called limit. We do the session schema collection thing again. And here we call collection.find, and then we call .fields. And here it's a string of the fields that you want to return and their alias. Now, it may seem odd that we have to do first name as first name, but with the Java connector, if you don't alias the column, even if you wanted to use it as the same name, you will get an error. So that's why there's first name as first name, last name as last name, score as score, course as course. And then I say, hey, I want to use date instead of date played. So I'm sorry, we use date played instead of the date property. And then we call the sort method. And the sort method, you basically are, it's kind of like the order by clause. So you do score ascending, date descending. So this way, it'll show the lowest scores first. And if there are two golfers who had the same low score, the most recent one wouldn't happen first. And then we again call .limit. We call clean results, close the session, return the docs. If we go here to best scores, you see I'm just limiting it to 10. We click send. You'll see that the count is 10. And then you'll see the scores. It shows the course was Locust Hill Golf Course on the front 9. This was 3 years ago. And Christopher Hilpert, which just to let you guys know, none of the names in here are real except for mine. I actually clean up the data before I import it into my demos for here. So the demos that I use, when you see my scores, it's actual scores that I shot. Whereas the last names of everybody else has been changed. So Chris is the guy's real first name, but Hilpert is not. And you'll see that he shot at 29. Now, for those of you who may not play golf, 29 is a fantastic score for 9 holes. And if I didn't witness this because we were playing against Christopher that night, and we got our asses kicked, I wouldn't have believed he shot a 29. But he was like on fire that night. He couldn't miss. He couldn't hit a bad shot if he tried. I mean, it was cool witnessing. I just wish it didn't happen when we were playing against them. So next we're going to talk about, so limit and offset are one way that we can limit data. But again, there's going to be times where you're not going to want every row based on, or you're not going to want every condition. So we're going to have to try and figure out a way to be like, all right, how can we get the data when a certain property is equal to or less than or greater than a particular value? And that's what we're going to show here by using conditions inside of a find method. So I created an endpoint called get rounds under par, which it retrieves all the rounds of golf that were played that were under par. That's pretty self-explanatory. And in the get rounds under par, again, we do the session schema collection thing. And you'll see here, when we call collection.find, we actually pass in a string where we say where score is less than course.par. And what we're doing here is we're basically creating our where clause. So to put this in SQL, parlance, we want to retrieve data where the score that the golfer shot is less than what par was for the course. And in our fields method, you'll see we're doing the first name, last name, score. But instead of pulling back the entire course object, we're only pulling back the course name. So here we're using a dot delimited path for course.name as course. And then we do date as date played, and then we're sorting it by the date descending. So what we're going to see is the most recent golfers who had a score under par. And if I go to get rounds under par here and I click send, you'll see that in the data that we have, there's been 187 rounds under par. One of them actually happened on Tuesday on the back nine, where Terry Monahan, not his real name, shot a 34. What's really impressive about this is the fact that at Locust Hill Golf Course, the back nine is much more difficult than the front nine. So the fact that he was 2 strokes under par on the back nine is really impressive. But you'll see here that instead of getting the entire course object, it just pulled in the name of the course. So now we're going to talk about binding data. Anybody who works on any type of application, specifically web applications, should know, and if you don't, you're going to learn right now, that you never, ever, 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 ever trust user input. And what that means is you always need to make sure that you validate your input, that the data is the data type that you're looking for, which is pretty easy to do in Java, but also that it's not going to do anything that you don't want it to. So by binding data, we can actually prevent things like SQL injection. And here we're going to do, we have an endpoint called get by score, and we have an optional value of, or optional parameter of score. And if score doesn't exist, we're going to say, show me everybody that has a score of 45. Now, it may seem odd that I picked 45, but that's because when I first wrote this particular presentation, this particular code, I had like 4 45s in a row, so it was easy to see one of my scores pop up without me having to do anything else. And then in the get by score method, we pass in the score that we're looking for. We do the session schema collection thing. And in collection.find, you'll see we do score equals :score param. So we specify the parameters, the binding parameters, very similar to the way we can in other languages. And then we call .bind. And we say score param is equal to the score value. And what this is going to do is, and it's more important on string values, that this basically tells MySQL, we're going to treat this as a string. If there's any extra characters in there that would make you think I want to run other commands, don't do it. Just treat it as a string. And then in fields, you'll see this is something that I think is actually really, really cool in Document Store, is instead of breaking the golfer's name up into first name and last name, we're actually using the concat method of MySQL to concatenate the first name and last name with a space in between, and then aliasing that as golfer. So you can actually use the result of a MySQL expression or function as a value when we return data from our documents. And you see we have score as score, course name as course, date as date played, and we're sorting it by ascending, score ascending, date descending. So it's going to be the earlier scores first, but honestly, I don't know why I kept that in there, because we're only getting stuff based off of one score anyway. And then we do the clean results, close the session, return the values. And if we look here, if we go to get by score, you'll see we're calling get by score, and I'm passing in a value of 43. And lo and behold, look at that. Scott Stroz shot a 43 this past Tuesday. That's not a great score, but it is my best score in the golf league so far this year, which made me very happy. And I was kind of under pressure because I always do this demo to show my most recent score. So I really didn't want to shoot a big number on Tuesday. And you can see that the name is concatenated with my first name, a space, and then my last name. I'm going to show you another example of using bind when we want to do like a like comparison. So there we were like, hey, where the score equals this. Now we want to do with where a property name is like this value. And what we're doing is we're going to get information by golfer where there's an optional param called last name. If we call this endpoint without passing in anything for the last name, then we're just going to get everybody back. It's just the same. It's basically the same as calling the list property or the list endpoint. And in get golfer, we do the session schema collection thing. And we do call.find, lower last name, like last name param. And then when we call bind, we do last name param, and then we do last name dot lowercase, and then we concatenate the percentage sign on there. So we're doing a like where we're providing the beginning part of the string we want to search. So if I typed in S, it would return everybody's scores where the golfer's last name begins with S. Now, something here that when I've given this demo before, I've given this demo for Java as well as using Node. And I like this example because it shows how the different pieces work together. If you look in the find argument, or the argument we're passing to find, we use lower. And we use lower there because that is the MySQL function to lowercase a string. So we're saying that the lowercase value of last name is like the last name param. But when we call the bind, we actually call last name dot to lowercase. And the reason why those are different is because in the find, we need to define it as the MySQL function, whereas in the bind, we're still in Java. So we have to use the Java way to get lowercase. So that's why we use two different things there. And then you'll see we're sorting by last name, first name, and date, descending, clean the results, close the session, return the values. And if we do get score by golfer, you'll see that I actually have my name up here in the URL. We click send, and you'll see that I have 291 rounds of golf in the database. The most recent one was my 43 pat on my back from this past Tuesday. But if I wanted to look up somebody else, so let's say we want to do we'll look for Sharp, and you'll see here that we have scores for somebody named Todd Sharp. Todd Sharp is not in the golf league. Todd Sharp is actually a very good friend of mine. Some of you may actually know him. He used to work at Oracle, and I know he's done demos and talks and stuff like that before that were around Java. And just to show you how the like works, I'm just going to search for CAM, and I click that, and you'll see there's 106, and you'll see that the first name is Raymond, and the last name is Camden. Again, Raymond Camden does not play in the golf league. Raymond Camden is another close friend of mine who has never held a golf club his entire life, and I just throw his name in there, mostly because the golfer that I use the golfer whose name I replace with Ray Camden, it's one of the better golfers in the league, and it makes it to me, it's funny that Ray Camden, my friend who has never picked up a golf club, actually has better scores than me, who's been playing golf for 40 years. So everything we've talked about so far, we were talking about the golfers or the individual rounds. And what if we need to group our data? What if we need to aggregate our data? How can we do that when everything is a JSON blob? Well, you're about to find out. So here, I create an endpoint called get course scoring data. And what I thought would be interesting here would be to get information about all the scores that take place for a particular golf course. So in the method in our service called get course scoring data, We do the session schema collection thing again. We go collection.find, so we're getting everything. You'll see in the fields, we have course.name as course name. And then we're calling round, average, score, and then 2. So what this is going to, now this is we're calling the average method on the score, and then we're rounding it to 2 decimal points. Remember, these are the native MySQL functions that are doing this. And then you'll see we have min and max, where we have to cast scores unsigned. The reason why that is in there like that, where we have to cast the score as unsigned, is because there's a bug in Document Store that I'm still waiting for the engineering team to fix. Whereas if I didn't do that, then the values returned from min and max in this particular case would be strings and not numbers. And that's a problem because if there's a score in the database of 100, that is actually going to be returned as the lower score than, say, a 40. Because in strings, 100 comes before 40, even though numerically it doesn't. And then we call count. So we count up all the scores to figure out how many number of rounds we have. And then we group it by course.name. So now our results are actually going to just include information about each course that is in the database. And then we clean the results. We close the session. We return the values. And if we go over here to get course data and click send, you'll see that it comes back as 2. So we have the front 9 and the back 9. And let me expand this so you can see a little bit better. So we have the average score on the front 9 is about a stroke better. About a stroke better than the back 9, which actually is expected because the back 9, as I said, was more difficult. Now, here's the funny thing. When I first set up these demos and I ran this particular endpoint, and I saw the highest score was 89. I'm like, that's not possible. That's got to be wrong. There's got to be an error in the data. So I actually went through the web application and found the round that had this as the 89, and it was not a mistake. This golfer actually shot an 89 for 9 holes. So on the front 9 at this course, we've had an 89 as the highest score, 29 as the lowest score, which means between the highest and the lowest, there's 60 strokes. And a 60 on 9 holes is still a bad score. That's how bad the 89 was. The 89 was so horrific that the difference between the highest and lowest was still a bad score. And you see for the back 9, the highest score is an 83, lowest score is a 31. And in case anybody is wondering, yes, the 83 in the back 9 was shot by the same person who shot the 89 on the front 9, just in different seasons. So one of them was 1 year, one of them was another year. And you see the number of rounds is different. And that's mostly because over the years, we've had rainouts. And for example, there might be times where we have a rainout when we're supposed to pay the back 9. But when we make that up, we wind up switching everybody over to the front 9, but just because of the way the schedule falls. So that's why there's such a big disparity between the number of rounds on the front and the number of rounds on the back. So here is my absolute favorite demo when we're talking about Document Store. I sat when I first put this presentation together, and this is I've had this presentation in one form or another for about 3 years now. I was trying to find a query that I could write that would be, I shouldn't say, I was trying to get results that would be difficult to do in other solutions. So I wanted to come up with a really complex query, like a way that, you know, if people were watching this and they were using other NoSQL implementations, they'd be like, I don't know how to do that. So what I came up with was, I was thinking one day that if we took the best score on every hole, regardless of who it was and when it was, and add them together, what would it equal? So basically, what we're saying, this would be like the glory round. If we could play each one of the holes and use the best score any golfer in the golf league ever shot, what would the total be for those 9 holes? And what I did is, and this is where the 2 database connections come in, because I'm going to show you how to do this using Document Store, and then I'm going to show you how to use this using Micronaut data and annotations. So you'll see there's an optional parameter here called source. And if source doesn't exist, we call score service dot get aggregate scores. And if source does exist, so it doesn't matter what we put in there as long as there's something there, we will actually call score repository dot core summary. And to break that down, so here is the score service where we're actually using Document Store to run this query. You'll see the one difference here is all we do is get the session. We don't get the schema, we don't get the collection, because when you're using raw SQL, you don't run the raw SQL against the schema or collection, you run it against the session. Let me zoom in a little bit. So, and then this query actually starts with a common table expression. And a common table expression is really nothing more than a named query result that you can use inside of a query and treat it basically as if it's its own table. And in this particular case, what I'm using it for, and it's what you use CTEs a lot for, is I'm kind of pre-aggregating data. I realized to get this data the way I want, I need to first get the lowest scores for each hole, and then I need to sum them up. And the only way to do that in one query was by doing that first step in a common table expression. So what we do here is we say with ag scores, that's basically how you know it's a common table expression, as, and then we do select doc, because remember the column we're dealing with in the table, which by the way is named scores, that has the JSON data is called doc. Now, next to doc, you'll see there's a less than, greater than, greater than. What this is basically saying is we're going to use the doc column or the doc JSON, and this is the path we're going to use. So when we're talking about pathing in JSON documents, when we're using raw SQL, $ indicates the root of the document. So when we say $.course.name, what we're retrieving is the name property on the course property off the root document. And you'll see here we alias that as course, and then we have min score, max score, and number. And I'm going to explain where those come from in a second. And then you'll see it's from scores. Now remember, scores is the name of the table that is holding our JSON documents. Then we use a method called JSON table. Now, JSON table is a really handy function to use in MySQL with JSON if you have an array of data and you want to get information out of that array. So what JSON table does is it basically takes an array of data and treats it like a table, or allows you to treat it like a table. And it kind of MySQL on the back end kind of handles doing the join on its own, so you don't have to worry about it. So when we call JSON table, the first thing we need to do is we need to pass in which JSON we're dealing with. So in this case, again, we're using the doc column because that's where we're storing our documents. And then we use $pound or $period whole scores, bracket star bracket. And this is saying we want to use every value that exists in the whole scores property, and the whole scores is actually an array. And then we define the columns that are going to exist in this table that we create using JSON table. And the first column we're going to create is score. We specify that it's an integer, and then we specify the path to that value. Now, in this particular case, the $ is not talking about the root of the JSON document. It's talking about the root of the particular instance of whole scores that we're dealing with in this particular iteration. So in whole scores, it's an array of objects, and each object has a property called score, and each object has a property called number. And that's what we do. We define those columns. So if we go back here and you see we do min score, max score, and number, that's where it's getting it from. It's getting it from this column definition here. So the number we do, again, we specify it's an integer, and then the path is $.number, which again, that $sign in this particular case is not the root of the document. It's the root of the particular object that we're using in the iteration. And then we say group by course and number, order by course and number. So this way, the values of the course are grouped, and the whole numbers are going to be grouped as well. So that's the end of the common table expression, and I know that because of the parenthesis here that's the end of up here. So once we have that the common table expression, now what we do is we do select JSON object. Now, JSON object is a way that you can actually take relational data or JSON data like I'm doing here and return it as JSON. And JSON object takes pairs of arguments. You can't have 3, 5, 7. You can only have like 2, 4, 6, and so on. And the first argument that you pass in the pair is the name of the property that you want to set. And then the second argument in the pair is the value we want to set it to. So here we're going to have a property named course name, and we're going to set it to the value of course. And then we have a value of best score, and we set that to the value. I'm sorry, we have a property named best score, and we're going to set that to the value of the sum of the min score values. So remember, min score is in the CTE. That's the name of one of the columns. So we're going to take all the values so that in the CTE, it will have 9 values for the front, 9 values for the back. Here we're saying add those up. Okay. And then we say from ag scores in this case is the actual CTE itself, or I should say the results of the CTE. And then we group it by course. Thoroughly, thoroughly complex. This took me a while. It took me a while to figure out what example to use, and it took me even longer to figure out the query to do it. But this was really fun to figure out. And then once we have our query, to get our results, we do session.SQL and pass in the string that we just created, and then we do query.execute, and then we actually have another result or another method to clean the SQL results, because it kind of happens the same way. Or this kind of the same thing kind of happens with that particular data that happens with the other data. We close the session and we turn the value. Now, when you use Micronaut data, we can kind of make this a little bit easier when you're using the raw query. Here I have a score repository that it's an interface that extends a generic repository. And then we have we use the query annotation where we pass in the same query. The only difference is we're not calling JSON object here. We're actually just pulling back the course name and the best score properties. And then we're returning an array list that's full of course summary DTOs whenever that gets called. And you see we call native query equals true. So when you actually call course summary on the score repository, Micronaut data goes and does its own thing to pull the information back, and will actually, you'll see it actually displays the data differently, so you can actually tell which one I'm using. So if we go over to get aggregate course score, so you'll see there's no value at the end here after get aggregate course score. So that means we're going to be using the document store implementation. And if we click that, you'll see that it shows that on the front 9 and the back 9, the best score, if we took the lowest score of every hole that has ever been shot by any golfer, no matter when, is 20. Which if you're a golfer, that means that on the front 9 and the back 9, every hole has been eagled, which is 2 under par for the hole, except for 2. So there's 2 holes in the front 9, 2 holes in the back 9. That have never been eagled in the entire time that we have data for the golf league, which is again going back to, I think it might be like 13 or 14 years now that we have data in the database. And the funny thing is, when I saw this, I was like, all right, now I got to figure out which holes they were. But before, I challenged myself to figure out, could I guess which 4 holes they were? And I did. I was right. And I've asked a lot of people this question, and no one's gotten it right yet. So that is a bunch of examples of using the CRUD API for the R part of the of CRUD, which we're just getting data. So now what we want to do is we want to create data. We're going to add some data to the document store. And I have an endpoint called score, which you'll see here. It actually uses the post method. And we get the body of the JSON and we specify that's a JSON object, and we name it score. And then we do score service.add score, and then we actually have to call score.json string, so we get the JSON, and then we just specify whether or not the call was successful. And then inside of add score, we're back. Now, this is one of the few times where I do have some type of error handling, but we do the session schema collection. And here inside the try, you'll see we do collection.add, and then we pass the value of score, which in this case is a string, and we call it .execute. And then if there's any type of error whatsoever, success is set to false. Then we close the session, and then we return the value of success. So if we look here, if we go to add a score, I'll pull down, you'll see the body of the request that we're sending in. Now, in this particular case, I set the value of underscore ID. If I didn't pass in a value for underscore ID, it will be generated automatically. I set it here so that for the following examples, I don't have to go back and look up what the ID is and put it into Insomnia to show the demo. I know the ID is going to be 25,000, so it's easier for me to do the other examples. And you'll see, hey, look, the date was today, and I was at Westwood Country Club in St. Louis. Actually, no, I wasn't. Skippy Dingelhofer was. So here's an interesting tidbit I like to throw out. If you are ever working on a database and you come across a user named Skippy Dingelhofer, there is a better than fair chance I had my hands in that database, because that is a name I've been using for test data or test users for decades. Like literally my first job as a web developer, there was a user named Skippy Dingelhofer that I used as a test user all the time. So when we click send, we should get a result back that it was successful, and it was. And the way we can actually verify that is if we go over here and we do get by golfer and we search for Dingelhofer, we click send here, and you'll see there's one result, and it's the data that we actually put in. But what's missing is the actual data for each hole that was played. So the hole score data is missing. And we're going to talk about how we do that next. So now we're going to show how you can modify a JSON object that already exists in the database. So here I have an endpoint that I call hole scores, where we pass in the values of scores. We pass in an array of the values for the individual holes. And we call score service.add scores and pass that in. And then here you'll see again the data is a string, and because it's an array, we need to jump through a little bit of hoops here. So I get the whole scores and I parse the array to a string, and then we call doc dot on the document itself, because what gets passed in, we need to get the ID and we need to get the scores. So the value that's passed in, we need the underscore ID, because we need that to do the actual update. We do the schema or the session schema collection, and then we call collection.modify. And when you call modify, you have to pass in a parameter. If you don't, it won't let you, because that would be like doing an update without a where clause, and we don't let you do that. So here we're saying modify whatever row or rows where underscore ID equals the ID param. And then we call set, and we're saying set whole scores. So we're setting the property whole scores to the value of whole scores. And then we have the bind for the param. Now, when you use set, if the parameter or the property exists in the JSON, it will be updated. If the property doesn't exist in the JSON, it'll be added. And then I have my poor attempt at exception handling, where we do 6x equals false. We close a session and we return success so we can see if it worked or not. So now I'm going to go to update score, and if we look at the body here, you'll see we have the ID of 25,000, and then we have the individual whole scores. Now, I will tell you, I didn't go through. Yes, this afternoon I went and I found a golf course that was close to where you guys were, and I used their name and their address to add that particular golfer. I did not go through the scorecard and say, oh, hole number 1's a par 5. I'm going to make that change. Now, this is all just random stuff that would match up with the course that I normally play. So you see we have the array of whole scores and the ID. And when we click send, success equals true. And how are we going to verify that? We go to verify update. And again, we're doing get by golfer, passing in Dingelhofer, click send, and you'll see here is the ID of 25,000. And you'll see now whole scores actually exists in that particular document. Now, if whole scores existed and it was an empty array or we had to update something, we could have just overwritten that completely by using the same code where we use set. And then lastly, we're going to show how we can remove data. This particular case, we're using a get method. The endpoint is remove score, where we have a required param of ID. And that actually calls score service.remove score. And inside of remove score, again, we do the session schema collection thing. We call collection.remove. As with modify, you can't call remove without passing some type of value in. Again, that would be like doing delete from without a where clause, which is something you never, ever, ever want to do. So this is kind of the connector team's way of protecting people from their own stupidity. We have the bind where we say ID param is equal to the ID that we pass in. We call execute. If there's a problem, success is set to false. We close the session. We return the value of success. And then when we do remove score, you'll see we call the endpoint remove score with the ID of 25,000. We click send. You'll see success is equal to true. And then we do, to verify the remove, we click send. And you can see now we're searching by Dingelhofer and nothing comes back. Something I just realized I forgot in the course aggregate. I told you that there's one way I'm doing it with Document Store, one way I'm doing it with Micronaut data. If I add something to the end here, this is actually going to kick it over to use the annotated repository method. So if I click send here, and you'll see, pay attention down here because this will change. It actually changes so the course name is on top and then the best course on the bottom. And that's how you can see that there wasn't some wonky magic going on. That actually happened real time while I was showing it. I apologize for not showing it before, but at least I remember before I got to the end of the presentation, which, by the way, we're at. So a recap of what we talked about so far was we talked about some of the differences between NoSQL and relational databases, the pluses and minuses of them, gave an overview of MySQL Document Store, the anatomy of MySQL Document Store. We talked about the X plugin and the X protocol for connectivity, how to add the Java connector and configuring the connection, showed tons of examples of using the CRUD API, and then how we can leverage the power of raw SQL to run ad hoc queries. If you're interested in the documentation of Document Store, this is actually the QR code. I'm going to be sending this slide deck as soon as I'm done. So if you miss scanning this particular code in right now, don't worry, you'll be able to see it when the stuff's posted. Or actually what I'll do is I'll go back. So if anybody needs to contact me about this or anything else related to MySQL, you can email me at scott.stroz@oracle.com. I can also be reached at LinkedIn at scott-stroz and on Blue Sky at stroz.dev. And with that, that is the end of my talk. I thank you very much for being here tonight. I appreciate the Java group asking me to come and speak. This is something that I really, really enjoy doing. I wish I could be in St. Louis to do it in person, but unfortunately, I was unable to do that. So I'm going to go back and keep that the QR code up there. And I didn't see, and it's hard for me to see with the way PowerPoint took over my screens, if there were any questions during the talk. Let's see if I can pull up.
Okay. Well, normally at this time, we kind of give a round of applause here to our presenter. Zach, are you able to see if there's any questions or anything that have accumulated or from anyone in the room? And Zach, I think you're muted.
How's that?
Much better.
Excellent. Okay, there was a round of applause here. Let's try that again, guys. There we go. All right. Okay.
What was the fireworks behind me? That was awesome.
That was pretty cool. I don't know where that came from.
Hold on, was that me? Or was that no? That was the applause.
Yeah, the applause.
That's awesome.
Virtual confetti. That's awesome. Any questions for Scott? Oh, this one right here.
You said that there will be a schema added by default to any document which we add. So that schema, I mean, so how do we? I mean, I didn't see you adding to schema every time you added a document. So
no.
I mean,
So are you
schema also every time we insert a new document to the collection? Or?
Are you referring to the validation, like the column underscore JSON underscore schema? Is that what you're referring to?
So I'm referring to, I mean, initially during starting, you said that there will be 3 columns added by default. One will be underscore PD, and the third one was schema. So
so if you don't, that will actually get added every time you add a document if you defined the schema when you create the collection. So when you set up some type of validation or a schema definition, when you create the collection, that column will get populated with that value every time you add a document.
Okay. So it will be same schema for every document, right? I mean, every document.
No.
Okay.
Keep in mind, you're not necessarily defining what the schema is going to be in that particular case. What you're doing is you're defining the rules that the schema has to adhere to.
Okay, got it.
So in that particular case, if you're saying we always want to make sure that score is a number, you would actually define that. And I can't remember the syntax because it's been a while since I've done that. You would actually pass that when you create the collection. So when you call schema.create collection, and you pass in the name, you would also pass in the value you want to use for the schema validation.
Got it. Thank you.
You're welcome.
All right. Any more questions here in the room? Okay. I think we're good on this side, Bruce.
Okay, I just had a couple of questions. What type of use cases do you generally see for these sorts of document stores besides just golf scores and things like that out in the wild? And how does it compare to other NoSQL databases? I'm thinking of something like maybe MongoDB.
So I'll answer the first question. A lot of times that I've seen people implement NoSQL solutions is when they don't control the schema. So there's a lot of applications out there these days where they ingest data from third-party sources. And it's entirely possible, since you don't control the schema, that the schema could change. And it doesn't really make sense to try to have your process pull in the data, massage it to fit your database. Because if it changes, then you need to change the code that ingests it, then you need to change the code that stores it, and then you need to change the code that reads it. So there's a lot of information there. And also, a lot of times that particular data is unstructured. And trying to cram unstructured data into a structure is a recipe for madness. So the two places I see it a lot are when the data is coming from somewhere else and it's being sent to us as JSON, or if the data is just completely unstructured. Those are the two main cases that I've seen. And I forget, what was the other question?
How does it compare to other
NoSQL
data stores? I'm thinking of something like Mongo, where they're document oriented like that.
So I can say it's comparable. There are going to be times when MySQL Document Store is going to be faster than Mongo. There's going to be times when Mongo is going to be faster than MySQL Document Store. A lot of it depends on how it's being used, the amount of data that's in there. MySQL Document Store can actually support JSON documents up to 1 gigabyte in size. So each document can be up to 1 gigabyte. which if you think about it, that's a lot of
That's
text.
pretty big. Yeah.
That's a lot of text. And obviously, the larger that, the more complex your schemas are, the more inefficient it's going to be when you're trying to search for sub-properties. So you have an object that has an object that has an object that has an object. It's going to be difficult to do that. And that's where you need to come in and create indexes. I can say the first time I ever gave this talk, which was the Node talk, I was at a JavaScript conference in New York City, and there was somebody from the Node, I'm not Node team, there was somebody from the Mongo team in the front row.
Okay.
And when I got done, he came up to me and he said, yeah, that example you did with the query, he's like, I don't know how we would do that.
Okay.
Which made me feel good. I was like, okay, cool. I was, I was kind of nervous that the Mongo guy was in the front row. But we don't do benchmarks. That's not something that we do as a company, but I do know from stuff that I've read, it's comparable. So given the same data set, the same data size, the same resources, you're going to get about the same performance.
Okay. Okay. Anything to steer you to one direction or the other, like a particular feature? Well, of course, your killer query, of course.
Exactly.
But anything else that might steer people towards maybe your solution as opposed to Mongo?
Well, one of the things that I've talked to people about before is people ask, if we have JSON documents, say you have in a JSON document, it has a property where there's a user ID and it's just a number. They're like, can you relate that to a table that's a relational table in the same database? And you absolutely can. You can actually relate it to a relational table that's in a different database. So you can actually run a query where you're pulling JSON data, or you're pulling data from a database, a table in a database that's different from the database where you're storing the JSON data. Now, you're not going to have the same type of performance as you would if you could define foreign keys, because you can't define a foreign key between a column in a table and a property in the JSON thing. But if you create an index on that particular value in the JSON document, you'll see a lot of the same performance boosts you would get as if you set up a foreign key, an actual foreign key relationship. So that's, to me, the biggest advantage is the fact that you can use raw SQL to query the data if you need to. So if anybody's running stuff where they have to do analytics on their JSON data and they're not using Document Store, they're gonna. Again, I don't want to say it's impossible. It is possible, but it's much more difficult to do with other solutions that I've seen than to be able to just write a query. Now, granted, I purposely chose a heinously complex query to show that, but that was by design, to show how complex you can get in your stuff. And you think about it, there really isn't a whole lot of different data. There's not a whole lot of properties in the JSON documents I'm storing in the demo, but the query was still pretty complex, and it hits a lot of different things, and common table expressions and JSON functions. And, there's a lot of JSON functions that are available in MySQL natively. And because that data is stored in a database table as JSON, we can use those functions to extract data a lot faster and a lot easier than we might, than if you tried to do stuff with just the API.
Okay. And that would be different from storing, say, JSON in a column in an Oracle database. I don't know if you talk to your Oracle cohorts at the same company, but they claim they can put JSON in a column.
Yep. Yeah, and the biggest difference there is the way, like, if you need to query by a particular property using raw SQL, I think their notation is different to specify what the property is. But there is a JSON data type in Oracle DB that I've never played with it. My experience with Oracle DB has been pretty limited to like 2 projects in my career.
Okay.
And none of them were using JSON, so I didn't have the opportunity to play with it.
Okay. Yeah, I might have to look back in some of our older presentations, and I think we had an Oracle database guy store JSON there.
Yep.
That might
there are people that have been storing JSON in databases for years. It's just, it was either as text or varchar or,
Right.
whatever. And the problem you have there is the fact that it's hard to search things because you have to either do, you actually
Right.
have to use regular expressions, or you have to use a like search. And the
Mhm.
problem there is if you have sub objects that have the same property names as other objects elsewhere, you're going to get mixed results.
Yeah. Yeah.
So
yeah, that'll get very messy very quickly.
absolutely.
Sure, I can see that.
One more question for myself, actually, here in the room.
Sure.
All right, go ahead.
So Scott, I enjoyed seeing Micronaut in your demo. We're actually in the building where Micronaut was invented here at OCI before it moved to Oracle, as it were. So I was just curious about the integration with this MySQL data store, both with Micronaut data. You showed a little bit with that query annotation. That was cool. How deep does that integration go? And then is there comparable integration for Spring data, for example?
So the only correlation there is the fact that I'm using a query. Right now, as far as I know, we can't use Micronaut data to actually hit the JSON and use the API that I was showing for most of the presentation. In order to get that, you need to actually use the XDev API and the X protocol using port 33060. So there's not a whole lot. I've actually talked to some people about would it be worth for like the person I was talking to was from the JPA data team. Is it worth trying to add a JSON data type for JPA and then kind of add similar functionality? But I don't know exactly where that stands in there. I basically use the annotation with Micronaut data just to show that it could be done, so that if you wanted to set up some type of report repository or analytics repository, you can write your queries and create your DTOs and have all your information come back just as you would anywhere else in Micronaut data.
Okay, so basically just as a mechanism for executing the query. That query
Right.
could be any valid MySQL.
Exactly. Yep.
Okay, anything else? Well, hearing none, then I'm going to hit the stop recording button here.